All right. Like I said, you totally can use whatever method that you have learned for in the past for piecewise functions. I like the table method, and so I'm going to teach you how to do the table method. I think it's easiest. It's not really the point of why this one is in this section, because you're supposed to think through what are the transformations of each of these functions. I just don't think it's as easy to graph that way, but if you like thinking of it that way, do that. I have adjusted some of these from your note sheet, so make sure that yours matches and you fill in the missing information. I think this first one, the functions match, but we have 3x squared if x is less than -1. -1 if -1 is less than or equal to x is less than 4, and then x minus 5 cubed plus 2 if x is greater than or equal to 4. All we're going to do, and make sure you take extra notes for yourself as to where these numbers, random numbers, are coming from, other things that we are doing, etc. But you just take one function at a time and create a table for it. So my first function is going to be that 3x squared. One of the things I'm going to encourage you to do is always think about the parent function. What is the shape of the parent function of this one? Well, that would be a parabola. More often than not, we're actually going to see that parabola start happening. If I were to only see like that much of it, right, we wouldn't really notice a parabola, but a lot of times we will, sometimes we won't. I'm going to make a table of points to plug into this. Here's where I'm going to get my numbers for the table of points. Come up to the inequality, and the number you see in that inequality is the first number in the table, whether it equals that number or not. Now, ours doesn't equal -1, but that's the first number I'm going to use in my table is -1. And then I'm going to pick numbers to fill in my table from what that inequality says. X is less than -1. So now I'm going to pick numbers that are less than -1. So go -2, -3. I can keep going forever. We're going to run off our graph real quick here because my graph isn't that big. But I put an arrow there to show myself that it does keep going in that direction. And that's actually the symbol I'll use in my picture as we get towards that end, is we have to put an arrow. On the other end, the symbol is either going to be an open dot or a closed dot, and that comes from our inequality. The less than, what is that, open or closed? Open. So you'll notice on my answer keys and stuff that I have it marked there with an open dot just to remind myself that that's there. But guys, all we do at this point is just plug it into the function. So I take a -1 and I put it into my function. -1 squared is 1 times 3 is 3. -2 squared is 4 times 3 is 12. -3 squared is 9 times 3 is 27. And we run off our graph really quick, okay? So I don't get to graph much of this one, but I will have an open dot at -1, 3. -2, 12 is already way off my graph, way up there. But we're seeing this parabola that's getting really big really fast, so I put a little curve as I head that direction, okay? And then we just switch to our next function. On our next function, here's the little note I'm going to give you. If your function is ever just a plain number, that is a horizontal line. So that's what my picture is going to look like. This is a horizontal line at whatever number that is. Now, you are absolutely welcome to still draw your table of points if you kind of are a method person that likes to follow the same thing each time. You can draw your table of points, but look what my table would look like. First of all, when they give me two numbers, that's the first number and that's the last number in my table. So I start at -1 and I go up to 4. I'm supposed to be plugging those into my function, but my function is -1. So my answer is -1 for all of those, right? Which is why you won't see me really make a table when it's just a number, because it's just a horizontal line at that number. We do have a closed dot at -1 and an open dot at 4. So at -1, I'll put a closed dot. At 4, -1, I'll put an open dot and a horizontal line connecting the two. Our last function is an x cubed is my parent. Again, I will start my table at whatever number I see in the inequality. So that's the first number in my table. This is an x cubed graph, so it's going to look something like that if I see enough of it to be able to tell its shape. I start my table at 4. I'll have a closed dot at 4 because of that or equal to. And I'm supposed to pick x's that are bigger than 4. So 5 or 6 or 7 and I could keep picking for as long as I wanted. It's probably going to run off my graph here pretty soon. Plug them into the function. Put a 4 in here. 4 minus 5 is negative 1. Negative 1 cubed is negative 1, plus 2 is 1. 5 minus 5 is 0, cubed is 0, plus 2 is 2. 6 minus 5 is 1, cubed is 1, plus 2 is 3. 7 minus 5 is 2, cubed is 8, plus 2 is 10, and then I just graph those points. 4, 1 is a closed dot. I did, but I just added 2 to each of my answers. Yeah, I just added 2 to each of my answers. So 5, 2, 6, 3, and then 7, 10 runs way up here, and you can see that we've got the little squiggle that goes through the origin and then starts to shoot up really high, really fast. Arrows on each end. You will have arrows on each ends of your graph always, okay? Dots in the middles. Only one type of function, which we're going to see on the next example, will have arrows in the middle of the graph. So all I'm doing is making tables of points for this. We don't even really have to worry about the transformations or anything. Questions on that? Okay, I definitely changed the functions on this second one and the interval, so make sure that you get yours to match mine up there. I think these will be a lot better examples for us. X minus 5 is if x is less than or equal to negative 2. 1 over x if negative 2 is less than x is less than or equal to 2. And then x minus 3 cubed if x is greater than 2. All right, one function at a time. So let's start with that top one. Start my table at negative 2. Our function is x minus 5. That's just a linear equation heading one way or the other, either up or down. Start my table at the x value that's in that inequality, so negative 2. I'm supposed to pick x's that are less than negative 2, so like negative 3, negative 4, so on. It does say or equal to, so we'll have a closed dot there at the negative 2. Plug those into my function, so negative 2 minus 5 would be negative 7. Negative 3 minus 5 would be negative 8. Negative 4 minus 5 would be negative 9. Put those dots on my graph, so let's see. Negative 2, negative 7 would be a closed dot right there. Negative 3, negative 8. Negative 4, negative 9. And it's going to continue on in that direction. Make sure you have an arrow on the left side of that line. Okay. Now, the middle one is where our table of points can come back to bite us, because in my table of points, we are doing the function 1 over x from negative 2 to 2. Normally, I'm going to do it over here so we have more room here. Normally, I would have told you to say negative 2, negative 1, 0, 1, and 2 in our table of points, right? Because that goes from negative 2 to 2. But can we plug 0 into this function? No. That is why you need to take really good notes on this one. That can't happen. So this is kind of a special case where we have to just go back and look at the parent function. I can still plug those other 4 options in, but you have to remember the shape of this graph. So negative 2, if I plug that in, I would get negative 1/2. Negative 1, if I plug that in, I'd get negative 1. 1, if I plug that in, I get 1. 2, if I plug that in, I get 1/2. And I can draw those points. We got an open dot here, a closed dot here. See, closed dot at 2/2. Oh, here's 2. A dot at 1, 1. A dot at negative 1, negative 1. And an open dot at 2/2. Okay? Well, here's where people make the mistake, is they just want to connect the dots. But do you remember what this picture looks like? This picture looks like this, doesn't it? Yeah? And what we are essentially seeing, if I were to graph this, is from 2 to negative 2. So we have to make it look like this little section in here. So starting here, I'm going to go down along my y-axis, right? Isn't that what that graph does? And then on this side, it's going to slide along my y-axis and stop at 2. So that's where our table can kind of hurt us, is if we don't remember what that graph looks like. And it only ever happens with a 1 over x type of graph. So look for that guy. All right, so then we can just follow our normal table of points for this last one, x minus 3 cubed. Again, always keeping in mind the shape of our graph. That's an x cubed graph, which is that little squiggle. I'm going to start my table at 2, because that's what it says here with an open dot. I'm supposed to be picking x's that are bigger than 2, so 3, 4, 5, so on. Plug them into my function. 2 minus 3 is -1, cubed is -1. 3 minus 3 is 0, cubed is 0. 4 minus 3 is 1, cubed is 1. 5 minus 3 is 2, cubed is 8. We can keep going. Open dot at 2, -1. Then we're at 3, 0, 4, 1, 5, 8. So there's our little squiggle through the origin and then getting really big really fast. Questions on that? Okay. The last one I'm going to let you try on your own. Work ahead of me. So I'll zoom in here on those 3 functions. I will come around and help.
If you added a couple more, you would see that the V shows up. Yep.
All right. Let's go ahead and talk about filling in our tables and graphing our pictures. One of the things is there is no set number of points to pick on the outside ends of a function. For example, on this first one that we're supposed to start at -5, I kind of tend to pick 3, but if you need to pick 4 or 5 or 6 to be able to see the shape, we're looking for a parabola, and you're usually going to see that show up. So make sure you pick enough to see the shape of that parent function. So I'm supposed to start at -5. It's going to be an open dot. I would pick maybe -6, -7. I'm looking for a parabola to show up. So if it doesn't show up in that, pick more numbers. Okay? Plug that in. -5 plus 6 is 1. Squared is 1. -6 plus 6 is 0. Squared is 0. -7 plus 6 is -1. Squared is 1. If I put those dots out there, we've got an open dot at 5, -1, at 6, 0, 7, 1. That is where the vertex of our parabola happens. We see that U starting to happen. That's the shape we're looking for. Okay. The next one, yes, I can make a table for this, but all of my answers are going to be 7. Remember, if it is just a plain number, that's a horizontal line. And that's a horizontal line that's going to run from -5 up to 2. All of these answers are going to be 7 between those. It's going to be a closed dot at the -5. It's going to be a closed dot at the +2. So -5 up at 7, +2 up at 7, and connect the 2. The last one that we're looking for is the shape of a V. And again, I don't have a set number of numbers that I should pick. I'm going to start at 2 with an open dot and pick numbers that are bigger than 2. So like 3, 4. If I'm not seeing the shape by then, I would pick 5 and 6 and see if I can start seeing a V happen. So continue on in that direction. As I plug those in there, 4 minus 2 is 2. 4 minus 3 is 1. 4 minus 4 is 0. If I stopped there, we would not have seen the shape. So keep going. 4 minus 5 is -1. Absolute value of that is 1. That's where the V started happening in this one. And so I would put an open dot at 2, 2. We had 3, 1, 4, 0, 5, 1. We start seeing our graph turn around and head the other way. That's where our absolute value of graph shape starts happening. So I picked all the way to 5 to be able to see it. Any questions on that? All right. Your assignment tonight is a worksheet. You're doing this 1.5 worksheet B. I will put that last one back up there if you need it.